Carson.
Would take up like our town. Like Eli wouldn't bet if the night decided to record up to bets.
Perfect. How funny.
All right, here we go. Multivariate literal linear systems and row operations. Fun, fun. All right, so we're going to work with linear systems, and we're going to use some elimination methods to figure out linear systems, and then after lunch we'll figure out other ways of doing it. A matrix is in row echelon form if the following systems or following conditions are satisfied. Rows consisting of entirely of zeros occur at the bottom of the matrix. The first entry of each row should be a 1. Then the column subscript of the leading 1 entries increases as the row subscript increases. All right, so finding row echelon form. All right, if we're solving this system by row echelon form, what we do is we do math to these, so we make zeros start appearing, okay, in kind of a diagonal format pattern, okay? So how do we make a 0 here? Well, what they did is they switched rows 1 and 2, and then, did they switch rows 1 and 2? No, they didn't. Well, they did, but then they multiplied by -1 as well. So they took -1 times this row and switched it with this row. So when you switch rows, it's a 2 for 1 right there, okay? Then they multiplied row 1 times -2 and added it to row 2, and that's how they got the 0 here. And then it became this. Then to get this 3 out of here, they multiplied row 1 times the -3 and added it to this, and then they got that. So then what they did is took 1/13 of this row, and you got this crazy row, and then multiplied -14 times this row and added it to this row to get this crazy row, and then divide or multiply, or basically multiplied by the reciprocal to get this row. And what happens is then that you know what the solution is, okay? But we're going to find an easier way of doing it than that, okay? So here's matrices, okay? So we're going to have a matrix of 2, 3, 2, -3, and 0, 2, 2, and 10. Now, we already know methods of solving these, which is much easier, but I'm going to show you how we do it this way, okay? So what we want to do is figure out the easiest way of doing it. So what I'm going to do is I'm going to divide this row by 2. So I'm going to have 2, -3, that was a 2, -3, and 0, and then we're going to have 1, 1, and 5, okay? Then I'm going to flip-flop those 2 rows. So I'm going to have 1, 1, and 5, and 2, -3, and 0. Yes?
Why is it, if the top is a -3, then why is it the bottom a -2?
It should be a -2. That's my fault. Thank you for correcting my error. Then, what we're going to do is take row 1 times -2 and then add that to row 2. Okay? Maggie, you got to pay attention to all this because not paying attention is going to get you like super lost. Okay, so we're going to take row 1 times negative 2 and add it to the next row. So 1 times negative 2 is? Negative 2 added to 2 is? 0, because we want to get 0 as the first number in this row. Okay, and then if we take the next one, negative 1 times negative 2 is 2, plus 3 is negative 1. Then we take 5 times negative 2, which is negative 10. If we add to row 2, we get negative 10. Then what we're going to do is multiply row 2 by negative 1. So I get a positive 1 there. So I get 1, negative 1, 5, 0, 1, 10. So from this, I know that 1y equals 10. Okay, so 1y equals 10 because I eliminated because I got a 0 there for x. Okay, so if I know 1y equals 10 and I plug it back into here, the top row says x minus y equals 5. So if y is 10, x must be, what minus 10 is 5? 15. So if I take 2 times 15 minus 3 times 10, that's 30 minus 30 is 0, right? It solved my equation. If I take 2 times 15 is 30, minus 2 times 10 is 20, which is 10. It solved my equation. Okay? So we must know x is 15 and y is 10. Now, that was a crazy, not very fun way of doing it, was it? But that's the way they're going to have us doing it to figure this out for now. Then after lunch, I'll have a new method. Okay? Are you going to have to do this very much? No. We're not going to worry about parabolas right now. So, discard. Let me go and show you what the first assignment will look like. It won't be so bad. Okay. Now, this matrix on this one is 1, 1, negative 3, negative 13, 0, 3, 1, negative 8, and 0, 0, 1, 4. So guess what? As we go down here, I have zeros here, which means I already have one of my solutions. I know P equals what? 4. P equals 4. Okay? If I plug that into my row above, if P is 4, 3n plus 4 equals negative 8. If I solve that, 3n equals negative 12, and divide by 3, what does n equal? Negative 4. So if I plug those into my first equation, okay, my first equation is x plus y minus 3 equals negative 13. Or, well, that's not x and y. It's n's and p's. M plus n minus 3p equals negative 13. So if I plug my negative 4 and my 4 in, m minus 4 minus 12 equals negative 13. So m minus 16 equals negative 13. If I add 16, m equals 3. That is my solution. Okay. Now, like I said, after lunch, I'll show you an easier way. This is easy because we're going to have zeros here and it makes it easy. So, they say on this one, if we take 3 times row 1 and add it to row 2, what are we going to get? What's 3 times 1? 3. Plus negative 3 is 0. Because that's what we're after, is getting zeros here and here. Okay? What's 3 times 9? 27. Plus 2? 29. What's 3 times 7? 21. Plus negative 1 is 20. Okay? And that's a transform matrix. We just did this to it, and that's all we're doing for this question. Okay? Here's another transform matrix. Okay? If we take 1/4 of row 1 and put it in place of row 1, what do we get? That's what this is saying. 1/4 of row 1, put it in place of row 1. I get 1, 3, 1. Easy peasy lemon squeezy. Okay, how did we make this into this? Little investigative process here. You switch row 1 and row 3. Looks like it. Switching row 1 and row 3 is R13. Okay, that's what it stands for. Switching those around. How do we get from here to here? Is the top row the same? Is the second row the same? Is the third row the same? No. So how did we do it? So we must have multiplied something by something and added it to something to get 0 there. So if I multiplied negative 3 times something, how do I get rid of 4? Well, the easiest thing is multiply this by negative 1 and adding it to 4 to get 0 there, right? So if I took this row plus this row times negative 1, let's see if that works for all of them. So that worked for the first column. Does it work for the second column? Take 3 times negative, or 3 So row 1, take row 2 times a number to get that. But I don't think that's any of these here. So I'm thinking the easiest way to do it is multiply that by negative 4 and adding it. I think that is what does it. So if you take row 2 times negative 4, you get negative 4. And if you add it to row 3, you get 0. Negative 2 times negative 4 is negative 12. Or no, negative 2 times negative 4 is positive 8, plus 2 is positive 10. That's it. That's what we must have done. Okay? All right, what is row echelon form for this matrix? This one is actually a little bit more difficult. Okay? Because I want to get 1, 0, 1, and 0, 0, 1. That's row echelon form. Okay? So, how do I get there? Okay? Well, I have 1, 5, negative 4 first. We already have that. So then I have to take this row 1 times what? Negative 4, and add it to this row to get a 0 here, right? So if I take 1 times negative 4 and add to 4, we get 0. 5 times negative 4 is negative 20. Plus 18 is negative 2. Negative 4 times negative 4 is 16. Plus negative 10 is 6. Okay? Now, to get a 0 in the bottom row, I'm going to take the top row times 3 and add it to the bottom row. When you have a 1, that's the easiest thing to do. So, 1 times 3 is 3, plus negative 3 is 0. 3 times 5 is 15, plus negative 11 is 4. Negative 12 plus 6, negative 6, right? Okay. The next thing I'm going to do is divide this by a negative 2. So 1, 5, negative 4, 0. If we divide it by negative 2, I get a positive 1. Divided by negative 2, we get negative 3. Okay. So then, if I take this one times negative 4 and add it to row 3, 0 times anything is 0 plus 0 is 0. 1 times negative 4 is 1 times negative 4 is negative 4 plus 4 is 0. And negative 3 times negative 4 is positive 12 plus a negative 6 is positive 6. I want to see what their final answer is for this. Just make sure I'm not steering you in the wrong direction. Yep, I'm steering you in the right direction. And then the last step is we're going to divide this row by 6. So our final answer will be 1, 5, negative 4, 0, 1, negative 3, 0, 0, 1. That's called the row echelon matrix. And you use row echelon matrices to solve something like this. So if we have 7, negative 6, 2, negative 7, 6, 2. Okay. If I add these two rows first, I'm going to get 7, negative 6, 2, and then I'm going to get 0, 0, 4. If I have two zeros here, and I can't get a 1, because there's no way I can get a 1 there, right? Ooh. It should be no solution. Oh, they just wanted me to write it down, the first one. Because it's going to be a no solution for this systems of equations, because we're going to get 0 equals 4. So, all right. My first equation from this one is 4x minus 4y equals 4. My second equation is 6x plus 4y equals negative 6.